Unequal masses on pulleys. When I first learned this, I had trouble wrapping my head around the idea that both of these masses were going the same direction, but they were also opposing each other. So I visualized this as two rockets that were trying to go in opposite directions and they were having a tug of war. I made a video on that method so you can see it if you want to. But here's another method to solve this. Instead of remembering FFA for Future Farmers of America, you could remember FMA for Future Mechanics of America, because this subject is in the mechanics section of physics. So we have our two masses here, 6 kilograms, 4 kilograms. They'll be pulling against each other. G for gravity will just be 10 meters per second squared. And then this is the only formula you need. MA equals F, mass times acceleration equals force. So mass of 6 kilograms times acceleration of 10 equals a force of 60 newtons. So we got 60 newtons pulling one way, 40 pulling the other. 60 minus 40 equals 20. That's our net force. That's the F part. And everything here will be net. Now we got net force. Now we do net mass. 6 plus 4 equals 10. Now we can do our acceleration. Maybe you could think of this as a net acceleration because you have two masses trying to go in opposite directions, even though they're still both trying to go down. Mass times acceleration equals force. The mass will be 10. The force will be 20 that we just added. So we solve for A for acceleration, 2 meters per second squared. So just remember net FMA. Next page I'll do tension. When solving for tension, it's still the same formula. Mass times acceleration equals force. When figuring out tension on a rope, it's best to think of this as one car pulling another car up a hill. The size of the car doing the pulling does not matter when it comes to figuring tension on the rope. The car doing the pulling could weigh a billion gajillion pounds, and that will not affect the tension on the rope as it pulls the other car up. So we only look at this 4 kilogram mass that is being pulled along for the ride. Next up, mass times acceleration equals force. This also equals tension. The mass of this block that is hanging here freely is 4 kilograms. Its acceleration from gravity is 10 meters per second squared. But we need to add the additional 2 meters per second squared. We just got this number on the previous page because this block is being accelerated upwards. 4 times 12 equals 48. That is the tension on the rope. Quick logic check. Make sure that this 48 newtons is less than the 60 newtons. And that is because the other mass is 6 kilograms, exerting a force of 60 newtons if it just hung there. And 48 newtons is less than 60 newtons because the larger mass is accelerating downward. Now that we know how to do that, we can do other scenarios where you just have a smaller mass pulling a larger mass off of a table. Add friction if you want to. That'll just be an opposing force. Otherwise, you just take this 4 kilograms times 10 meters per second squared. That gives you a force of 40 newtons. But that 40 newtons of force now has to accelerate 10 kilograms of mass instead of just 4 kilograms of mass. And you could also do this scenario here where a smaller mass is pulling a larger mass up a ramp. If that's a 30-degree angle, the sine of 30 equals 1/2. 1/2 of 6 is 3. So that means you need a mass larger than 3 pulling down on this to pull this other mass up if this is a frictionless surface.